This one should work.
Ah, it says meeting is now streaming live on YouTube. You've got it.
Yes. Okay, I think we are online. Let me just take the link and share the link on Facebook and everywhere. Okay, at the same time, you guys, you can start. We are starting now this webinar, Greening the Solar System. Our chair is Howard Bloom. So he will give the floor to our guests and to himself too for his speech. And after a short presentation, 10 minutes each, we will have a conversation altogether. And we will also reply to possible questions from our attendees. Okay, so Howard, it's up to you.
Okay, this is a panel on gardening the solar system and greening the galaxy. Actually, Alessandro has collapsed that down to greening the solar system. I proposed in a visual manifesto for the National Space Society that's been adopted as the National Space Society's vision, official vision, that we have taken one tiny poison pill of stone, one hostile, toxic gravity ball, where the temperature rose and fell 88 degrees every 3 hours, where first the planet was whipped by this poisonous substance called radiation. And then it was dipped in an equally poisonous stuff called utter darkness, where it went through four major aside from these major climate changes every 3 hours, it went, because it was tilted on its axis, it went through a series of very substantial climate changes every 365 days. We call those summer, winter, fall, and spring. And despite the hostility of this ball of stone to any form of life whatsoever, life has taken a hold here and has built a very thin onion skin on the exterior of the planet. We believe we have greened and gardened the place. By we, I mean all the children of life on this planet. We have barely begun. But if we could do it to one poison pill of stone, then it's our obligation to bring the process of life to other hostile balls of stone. And there are tens of trillions, there are actually thousands of trillions of those in the sky above our heads. Why is it our obligation? Because bacteria can do research and development as well as we can. Right now, 12 miles beneath your feet, bacteria are turning raw rock into the stuff of life, into material for biomass. So research and development's not just us. But we do happen to be the one creature on this planet that is capable of taking the grand experiment of life out of the gravity well, past the atmosphere, past the heavens, and to other hostile balls of stone in the sky. That's the premise of Garden the Solar System, Green the Galaxy. Adriano has brought together some remarkable people. Enrico is an ecological biologist who has studied everything from territory in Ethiopia to the Magella Massif, the mother of all mountains in Italy. And I'm doing this without notes, so bear with me if I get some things wrong. Giorgia has founded a large organic farm that's unique because it raises crops in completely sterile environments, like the sterile environments used in the manufacture of microchips. She has the only farm in Europe capable of doing that. Jim, I think, is here because he has helped Alessandro organize this event. Jim, hi, I haven't seen you in a long time. Emanuele and Alessandro have a project called Flower on Mars. Alessandro has shown in so many different galleries in so many different places in Europe that it defies belief. Berlin, Moscow, St. Petersburg, at a submarine base, in France. And he is the artist behind this project, but he prefers to present himself as a modern day shaman, as a person who can use scientific tools to help find what he calls the invisible immanent energy of the universe around us. Emanuele has been involved with little tiny projects like the International Space Station, where he was in charge of an entire lab, where he was in charge of fluid transfer, where he's been in charge of all kinds of things. And so he's been where the rubber meets the road in space for the last 30 years. So Enrico, you have a very interesting vision of what space can do for our understanding of life and for the future continuity of life. Do you want to go first?
Oh, yes. Well, thank you. Thank you for the presentation. Yeah, maybe it's better because we would like to. I'm sorry, we have to leave the meeting maybe a bit earlier than anybody else. And okay, if you, I don't know, Adriano, what's the agenda? Can we start? Do you need to
wait? I
meant
to say Enrico. Do you have to leave early, Emanuele? Because I meant to go to Enrico. And excuse my Zoom clumsiness. So can we skip over to Enrico right now?
Yes, of course. For me, there's no problem. They can talk. They can start, of course. No problem.
Okay, so maybe it's better if we share. Adriano, we cannot hear you. Adriano?
No, we're moving over to Enrico.
Of course, I have to unmute. Sorry for that.
I see. Okay.
No, we have a couple of friends that have to leave early because tomorrow morning they have to wake up very, very early in the morning. Therefore, I think it's a good thing to let Alessandro and Emanuele go first.
Okay.
Maybe Giorgia, the second,
right.
And then Enrico, and then Howard and Enrico. Okay.
And Jim?
No, Jim.
Okay, Emanuele, back to you. Sorry for the confusion.
Jim is not giving presentations. Maybe he will. Maybe we'll make some questions to our panelists. Okay. So, please.
Okay. Well, maybe it's better if we can share the presentation. Adriano, I don't know, but you have the presentation, so maybe you can put on the screen now.
No, you can share your screen if you like.
We can share you. Okay.
Yes, you have a green icon in the middle.
Okay, I see that. Well, okay, found. Okay, I think now you see the presentation. Let me put in the, well, I don't know how to, well, like this. Okay. So the idea is, of course, the project, of course, it's not my project. The project is, it has been defined by Alessandro Sciaraffa, and I'm just supporting him for the scientific part, let's say, the technological part. So the idea is to have something that is coming from the Earth, growing on another planet, on a place where people are not supposed to live today. The status of the project. So the Flowers of Mars is already did some little step, because Alessandro was did a collocation in France, in Cannes, at the Thales Alenia Space France, where he had some exhibition there. This happened just during the first lockdown for COVID-19, and also he got some funding from a call that is called Racconto Plurale, and this is already funded, so it will be, for instance, in Kazakhstan in next June, I suppose. Yeah, and this will be another step of this project. But generally speaking, the project is divided in 5 main, I would not say step, but stages.
Momenti di crescita.
Yeah, the growth stages, how Alessandro says. So the first one is mainly let's say constituted by the exhibition and symposium that Alessandro want to continue, because he already started last year, as I said. Want to continue in France with Thales Alenia Space. And this would be, you know, just the very beginning of the project. Said that, he expects to have a second step, a second stage called floral humus. In this stage, the idea is to involve people, to enlarge the community, to involve as many entities we can. And this will be supported also by the building a construction of a web community. So very likely there will be a web page, some social, let's say, web social initiatives to collect as much as possible any person, any entity that wants to join this project. Third stage. In the third stage, we'll have maybe the most scientific part of the project, because there we try to develop the plant, the seed, a plant that is able to live both on ground, on Earth, and on Mars. You know that on Mars we have, you know, to grow a plant, what you need is soil, water, and carbon dioxide and light, of course. On Mars we have at least soil, CO2 and light. We miss the water, at least at the surface of the planet, but we know that water is inside, can be found below the surface of the planet. So all the components for growing a plants are already there. The problem is, or at least the challenging, is to find a biology that is able to live both on Earth and on Mars. So this will be the main goal of this third step. And in this step also we will develop a sort of reverse greenhouse, as I call. So it's a greenhouse that is able to create on Earth the Martian environment. So providing the Martian atmosphere and the Martian soil and all, as much as possible, all the conditions we have on Mars. Well, for instance, from a lot of study made on plant grow, especially on the space station, we know that gravity is not an issue. Plants are not affected, are not influenced by gravity, but they just follow the light. So, for instance, the fact that on Mars we have just 1/3 of the gravity with respect to the Earth is not considered a problem, or at least it should not be a problem for growing a plant. Fourth step. In the fourth step, we have to make the plant. So we have to finally develop the biology for Mars, and to find also the money for the mission, because the project is very ambitious in the sense that we expect in some way to go really to Mars. maybe as a piggyback payload of a larger mission, but and the Flower on Mars can be a payload, a small payload of a larger mission, like you know, in ExoMars. You know, I don't know if you are familiar with this project, ExoMars, that is supposed to be launched next year. Yes, in 2022, they will drill an hole in 2 meter deep on the surface of the red planet to find trace of life. That's what they want to do. But this does not prevent also to plant a seed. So even ExoMars could be a potential vehicle. Okay, the project is already at the end of its life cycle, so it would be quite difficult to enter in this in the project. But in another project can host a payload like the Flower of Mars. So finally, the fifth and most ambitious step is to really have a flower, a plant, an earth plant that can grow under the Mars conditions.
Terrific. You've come in on just 10 minutes.
So I'm just said everything already, so we can skip the other charts. I believe this presentation will be made available to everybody. So what can we add? Okay, this is a quite interesting aspect that can be said. The idea is to put the seed in a bubble of water, and because this represents is similar to the way the life has been spread around the universe. We suppose, but specifically on Earth. Because the comets that are made mainly by water are supposed to start are supposed to be the vehicle that started the life on Earth. So this can be the same idea for moving let's say putting life, Earth life on Mars. I don't know if Alessandro wants to say something, and we just. Okay, so this. I think we have completed our view of the project, and if there are any questions, we're available to answer.
Okay, terrific. So Giorgia, you also have to get to an airport. Why don't you go next?
Sorry?
I was asking if Giorgia would like to go next.
Okay.
And praising you for your presentation, Emanuele and Alessandro.
Okay, I just remove it. Just a second.
Can you see my presentation?
I don't know if I've removed mine. I'm not sure.
We see you. Giorgia Pontetti is started, but the screen is black.
Yes.
Okay.
Now it's okay.
There we go.
It works.
Yes, Ferrari Farm,
Okay.
space
Great.
hydroponic alternative.
Okay. My presentation starts thinking that we will go to Mars. I don't know exactly when, but we have to go. And if we think about the current space food system, we know everybody that we have 8 categories of food. And those foods have a problem because the current shelf life is between 12 and 18 months. But if we want to think to go to Mars, we have to think about 5 years mission. And then we have to think about 5 years shelf life required for food. So the current food system becomes unacceptable because the shelf life is lower than the mission duration. So NASA has analyzed their thermostabilized food, and they discovered that after 5 years of storage, only 7 of the 65 foods are palatable. This means that they are not nutritional, but they can be eaten. This is not this is not the things that we want for the future of our astronauts. So NASA said that they have to study a 5 years shelf life challenge. It means that we have to think again, processing, packaging, formulation, and environment for food, because the nowadays food is not acceptable. So we have to find a balancing act between safe, nutritious foods and efficient use of resources, mass, volume, water, and so on. So we have to think about new concept, because on a mission to Mars, we will have no resupply mission from Earth. So we have to think that our astronauts have to live without resupply from Earth. So traditional life support system becomes unacceptable too. This is why the international community is studying about bioregenerative life support system. It means to recreate an artificial space biosphere like the ones we have on Earth. So plants inside these bioregenerative systems have a key role, because plants, as we know, can purify water and air, and can give fresh food to astronauts, and in the meantime can recycle the astronaut waste. So bioregenerative life support system are between the European 2020 Foundation scheme, are on the Global Exploration Roadmap, and are a working group within the Italian Space Agency, and we are part of this working group. So a space greenhouse is fundamental if we think about long-term missions on other planets. So the plants can not only give fresh food to astronauts, but also improve morale and decrease stress, because green therapy, as we know, can have this positive role on humans. Else than this, as we know, if we go outside the LEO Earth orbit, we have an increasing of radiations. And for example, if we think about interplanetary missions, we have 6 times the dose that is lethal for cancer. So if we add fresh food rich in antioxidants inside the astronaut diet, we can help them to fight the radiations. So growing plant when we think about a space environment, so we think about the moon on Mars or Mars, is not simple, because we have an extreme and complex environment to manage, and we have to identify the most resistant species to radiation, to different gravity, to different light, and so on. So if we think about space greenhouse, we have to think about hydroponic, which is a technique that allows to cultivate without using soil. In this sense, the water is used to transport nutrient salts. And so we can think to cultivate also on other planets. But we have to take in consideration that we need an artificial climate, we need probably an artificial lighting, we need a system to supply water and nutrients, we need to control pathogens, and we need to find resistant species to a different environment. Else than this, we have to take into account the gravity condition, which is different, the radiation dose, which is a completely different, and all the distance from Earth and the isolation. So about microgravity, my colleagues before me told the same that I'm going to tell, so that a lot of experiments have shown that else in microgravity, plant can complete the entire cycle from seed to seed. So the only difference that the scientists note is that the root grow in every direction instead of going down like on the Earth, because they sense the gravity on Earth. But they can do the entire cycle, so we can harvest with a different microgravity condition. Concerning radiation, as we know, going outside the LEO Earth orbit, the radiations are too much, and we have to manage it. But generally, the studies that have been done till now have shown that plants are more resistant to ionizing radiation than animals and humans. And in some cases, lethal dose for animals have no effect on plants. So this is a good notice, because we can think that we can find the suitable species that can natively resist radiations. So now the scientists all over the world are looking for species that have a reliable germination, low native microbial charge, and that are rich in antioxidants. And at the moment, they are studying durum wheat, soft wheat, potatoes, and soy. But if we go to look at the EFSA tables, we know that for an adult, we need about 50 grams of vitamins in order to fill the needs. And for astronaut, it is about 60 to 80 grams. So if we look to EFSA data intake levels, we can see that adding 90 milligrams of vitamin C, then vitamin A, K, and A, we can cover the entire needs of a human to be healthy. So studying some particular type of microgreens, we can sentence that mixing together different varieties of microgreens, we can give to the astronaut the EFSA daily intake, eating fresh food, not integrators. So I just want to show you some projects that are all over the world that have been done concerning Moon and Mars future plans. If we go to look at the Moon Village, we can see that they thought about different habitats, and they talked also about the greenhouses. So there are modules specifically dedicated to hydroponic cultivation on the Moon surface. The same is for Mars. If we go to to see this NASA Big Ideas Challenge, we can see that there is a Mars-sized dome and then a Mars greenhouse, which is made using hydroponic. And this is the internal view of the Mars greenhouse. So there is a strict connection between the home and greenhouse, because they together exchange something that is important to survive both. And this is a section of the internal dome. So we can see also here, there are greenhouses. And this is just to show you, those are NASA projects. They probably become a reality in the future. So we can think to colonize Mars, also adding greenhouse to sustain the people. So concerning these, Howard introduced me because we decide to realize in Italy the first plant able to demonstrate that we can cultivate regardless the external environment. So we can cultivate clean all over the world without competence, letting a computer cultivate inside of ourselves. And so we have realized this plant, which has 2 glass greenhouses and 1 LED-lighted phytophone, able to cultivate yearly tomatoes, crop, and basil. And now I show you some picture quickly, just to not bore you, but these are our tomatoes. So we have a clean room with inside plants, and this is our basil. As this, we have developed new generation LED lamps that are liquid controlled in order to manufacture vertical farms that could be well managed regarding the energy. And so about this, we have realized, co-financed by the Italian Defense, first shelter, which is a vertical farm, clean, in order to cultivate in extreme environments, microgreen, for an healthy diet for our troops. And this is what we have done. So we have a shelter, and there is a traditional shelter like the traditional cargo shelters that inside hosts a new generation farm able to cultivate autonomously for 600 people every 7 days. So we can have every 7 days 500 portions of our special salad in order to cover the data intake. And now we are cultivating the first saffron in vertical farm in order to demonstrate that we can also cultivate with high density and so high yield, also saffron. And finally, now we are realizing, co-financed by Lazio region, a project with the Italian Space Agency and Enea in order to realize a REC, which will be a first prototype of a space greenhouse. So it will be completely sealed regarding the external environment, and it will cultivate autonomously some varieties that we have to decide with Enea and DASI. And finally, we are realizing now a new 3D printer for food in order to think the food of the future. So in order to can real time produce high nutritional food also for the future of our astronauts. So I would like to leave you with this sentence. There's no way we can leave Earth without the plants. So thank you for listening me.
Thank you, Giorgia. Well, so I guess humans are plants' way of getting to space. Enrico, so your concepts are about how we use space to continue life and allow it to flourish. You want to explain to us? Oh, just one thing on Giorgia that I didn't mention. Giorgia has 2 engineering degrees in 2 separate areas. One of them is aerospace, and she's certified as a chef. So when Giorgia wants to turn a chart about foodstuffs into delicious food, she has the credentials to do it. Now, Enrico, over to you.
Thank you. Thank you very much. It was a very nice presentation that I like very much, the one of Giorgia. Of course, she told us several things that I had also in program to tell, but it was already said, so there's no question to repeat. And then if I can do my presentation just now.
Yes, please, Enrico. I just would like to remember to everybody here and also to the people that are listening to us that the call for paper for our Congress is still open until April 15. So I recommend all of us, if who not yet presented a paper, an abstract for a paper during our Congress in June, to do it before next Thursday, 15. Okay. Thank you so much. Go ahead, Enrico.
Thank you. I hope that, yes, thank you very much. Thank you very much to everybody that is listening us in this evening. And thank you, Howard, for his chair, and Adriano for having organized this event. And of course, I'm honored to speak in this group about something that I like very much, that are plants, of course. And I think that what Giorgia said is very interesting, and then she showed that something is going on, and that is very important, that something is going on, not only dreams or something that is impossible to reach, but it is very important that we are doing something on the Earth, simulating what could happen outside, and avoiding philosophical arguments. I think that it's time for men to look for resources out of this planet. And why it is this time? Adriano has written some book about why it is time to look for the space. Our ecological footprint is now in between 1.6 to 2 times the productive area of the surface of the biosphere. This means that the biosphere isn't able to restore itself. And then we are listening every day about the problem of global warming, global change, etc. But global warming is just an event that indicates the biosphere is under stress. So there's no question about we are under stress. And then we need to look what Adriano said the planet be. And then we need to go outside, of course. And there are many people that don't like this idea, but I think that we should go ahead in this direction. So for the expansion in the space, we should be interested in a very large class of organisms. Giorgia has mentioned some that are particularly important for the food, but we should look also for other organisms that are autotrophs. So what means? It means that they are able to produce organic compound from using simple things like carbon dioxide, and energy from light, but also energy from other inorganic chemical reactions. So we have two processes very interesting. One is photosynthesis and the other is chemosynthesis. And both are very, very important. Of course, when you think to greening the solar system everywhere, you are thinking about photosynthesis rather than chemosynthesis, but also chemosynthesis is very important. So the two reactions, the two processes are synthesized here in these two lines. The photosynthesis, you see, the entrance in the photosynthesis CO2, water, and in presence of light, you produce sugars, so glucose. And then it is released oxygen and water. That is very important because in this way you can see that the plants are regulating both the cycle of water and the cycle of oxygen, and also carbon, of course. But oxygen is very, very important for our life because it's going up, not only because it is inspired by us, but because it's going up and constitute the ozone layer that is blocking the radiation, other radiation that can reach the earth and then treat the other lives. The chemical equation from chemosynthesis is this one. You see, it's very similar. So it's just the oxygen here is substituted by another element, and light is substituted by oxygen. Oxygen is produce the oxygenation and energy for the process. So for building up sugar and releasing water and releasing not oxygen in this case, but the substance that is linked with hydrogen here. So these two processes are very important to be controlled, to be studied, for go ahead in the out of the space, for go ahead with the programs. And then we should be conscious that these two processes need a lot of research. And of course, the first process is characterizing the plants, and the second, what we call bacteria that are living even in the deep, in the ocean, and then are living on the rocks, and then they are doing very, very important activities in the biosphere. So if we think just to the most visible organism, they are the eukaryotes. Eukaryotes are the plants and animals who have the complete cells with nucleus. And Haeckel was providing this very nice tree showing the evolution of Plante, Protista, and Animalia. Of course, Plante are the ones with chlorophyll. Protista also, but Plante are the plants, the cormophyte are what we can see, and Protista are including all the plants that are living in the water, in the algae, the diatoms, and the phytoplankton, that we have to take into consideration, because when we are expanding, let's say, colonize is not a nice word, but when we are expanding our life in the space, we need water, and water is hosting a lot of life, bacteria and algae, and so this tree was done by several years ago in 1866 by Ernst Haeckel, that was the founder of ecology. This is a photo. Today, the tree is more let's say, more interesting, more complete, more scientific, because a lot of progress has been done in biology. So this tree is considered prokaryota, bacteria, and archaea, and eukaryota up there with Plante, Protista, fungi, and Animalia. So this is the tree that show in very, very big synthesis our history, the history of the life on the world. Another group of living organisms that is very interesting, and that Haeckel give importance to them, In fact, I show a photo of taken from Wikipedia concerning the life of Haeckel. Are lichens. Lichens are a mixture between protista and fungi, a mixture between these two, a symbiosis between these two, and they are very resistant, very resistant. They are living in very extreme environment, and then they look not affected by any gravity problem, and even not by radiations, by a lot of radiation. No difference of temperature and so on. So they are very, very important to, let's say, as elements of for colonization in the early stage of any kind of succession. So important. There are so many species that could be among those we could choose something for to be useful outside, and in doing this, the important concept is the ecological niche. The ecological niche that is it is a sort of hypervolume in the ecological space. I had this one is the light, but I go ahead. Ecological niche model. This is a model that is very important that we keep into consideration every time when we are trying to develop something that could be useful for greening the space out of the earth. So every factor, ecological factor, is an axis of this multidimensional space. And with respect each of this factor, the photosynthesis and also chemosynthesis is reacting like a bell-shaped curve. And also it is important for the organism and for the process, the time of exposition. Here this is a response, this is black, and the exposition, this is this red color. So the exposition, you can be exposed, and the process can be exposed, and it continues as soon we get near the optimum values. But as we go toward the minimum values that are necessary of factor that is necessary for the life, so the response is diminishing in this way. Then it diminishes also going toward the maximum factor. These two values, the minimum and the maximum of the factor, are defined here in the hyperspace, the hypervolume where a species can survive. So outside of this volume, the species is not surviving. So it is relevant, it's important to understand for each species that you want to bring outside, its niche, where what are the conditions?
Just a note, we're running out of time.
Yes, sorry.
Okay.
I go ahead. So what I mean by green solar system is not only to build greenhouses on the moon, on Mars, but also to build greenhouses in station outside in the space. So, like for example, the cylinder of O'Neill, the Stanford Bull, and which are shown in these two pictures. You see, these two pictures. In both cases, there is a dream. So to build up something like this, so a landscape that it reconstruct the ecosystems that we are living now. So this is, of course, this is a dream, but to reach this dream, we need to know all the ecology of the species. So their ecological niche, in order to reconstruct in these cylinders, in this environment, the ecosystems, the food web of these ecosystems. So there are, of course, as Giorgia said, there are already ongoing programs by NASA, and not only by NASA, but also by ESA, by Italian agency, and the European Commission is giving also support in the program Cordis from some experiments concerning the plants in the space. But I think that is not enough. In summary, what we need is to start to promote a strong acceleration in the study of the responses of photosynthetic process of plants, terrestrial and aquatic, in the presence of low atmospheric pressure, reduced gravity. That is not very important, but it makes sense, especially for the trees, if we want to plant trees. So if it's just small plants, is not important, but for trees, it could be important. Low CO2 concentration. In Mars, we have a very high percentage of CO2, but in low concentration. So the problem is to find a way to concentrate the low concentration of CO2. And then, of course, the radiation, ultraviolet, and other things. So the research needs a worldwide, and what I think that it's the research needs a worldwide interdisciplinary cooperation and a network of terrestrial and extraterrestrial laboratories. This is fundamental if you want to go ahead. And then this laboratory has to be done on Mars, as we have seen some ideas from Georgia, and space stations such as ICSS, where to study also, it was also important, study mutations and genetic-phenetic interactions, and also the possibility to create new plants, the genetic modified organism, adapted to extreme environment that would fit or create a new ecological niche. That has all 6 points that has to be taken in serious consideration, and then they have to be afforded, they have to be implemented in the research programs at the national level, also international level. That is very important. But to pursue this realization of such a network, of course, there is a problem, cultural, social, economic, and political problem. So there is not so easy. We have to convince people that that the aim is good. And then, of course, we have to find the funds, to find the financial resources. But about this, I put only this graph that you can see. This is the biggest military budget as percent of GDP of the nations. Saudi Arabia, for example, is giving 8.6% in military weapons. Israel is 4%, and so on. So United States is giving 700 billions for dollars for the army, and China about 390 billions. So there are a lot of money that's going in that way. So I want to stress just that it is not only, it is up to us the way in which we want to build an economy. So the economy is not something that God is give to us. We are building the economy. So it's up to us to choose one way to spend the money or another way to spend the money. So I think that in conclusion, there are a lot of resistance against the space renaissance, not our club, let's say, our society, but in general, the people are against the space renaissance. Many persons are thinking that before to go out of space, we should solve the problem we have on the Earth. But I think that a lot of problems have been solved on the Earth by looking at the space. The modern science started with Galileo, Leibniz, Newton, Kepler, all people that were looking in the space, not in the end, not at the Earth. So very little in the Earth. But all the big science, let's say, starts looking at the space, looking outside the Earth. So I am only an ecologist, I said, who thinks that the expand life in the space is a way to understand better the life itself, and to create the conditions for its continuity and evolution. This is very important point of view, because I think that we are not, our future is not the Earth. Many people are thinking that I am mad when I told that in 4 billion years the sun will finish its activity like it now, and then the solar system will collapse. But okay, for 4 billion years are many, but I think that time is flying, and then we have great responsibility toward the life. This requires hard work and research issues. So thank you very much. Sorry for if I was so in hurry, but I think that I hope that I was enough clear to explain what we need and what.
Yep, that was absolutely terrific. In the groups I run, Buzz Aldrin 15 years ago, the astronaut, convinced me to form a group called the Space Development Steering Committee. And one of the members of my group the other day proposed that because of the new forms of farming that we are creating with space in mind, we're about to enter an agricultural revolution as large as the agricultural revolution of 11,000 years ago, when we first invented agriculture. And presumably he means, because he pointed me to a site that talks about using containers as small farms, presumably he means reducing the amount of land that we need for farming dramatically and increasing productivity completely. Georgia, is that a wild dream or is that an actual possibility?
For me, it's an actual possibility. I dream about these. So I think that we have now all the competence to seriously think about these. So my dream is like those my colleague Emanuele and Alessandro is a flower on Mars.
So
we can achieve a massive increase in the amount of food available.
I think it's like what Enrico said. There are different problems, economical, social, political, and the technological problem. Technology for me is not a problem. I think that we can do this, but we have to change our mind. What Enrico said was true. A lot of people think that we have to think only on Earth, but I think that the genius of the story demonstrates that we have to take a look at space and then improve on Earth. So I think we have to change the state of mind to achieve these.
What's the nature of the LED lights that you've developed?
Sorry?
What is the nature of the LED lights that you've developed?
We made something that is mad because we start from NASA articles when they show which were the correct wavelength to grow plants. Then I decide to both one lamp of them on the market for each producer. And then I decide to in charge a research institute to test them. And I discover what I was thinking, so that this lamp, the technical data sheet was not telling the reality of the lamp light. So I decided to make an internal research project, and we decided to study a new lamp. And so our lamp, which the commercial name is Robot Lamp, is now ready to go on the market. And we decided to use 5 wavelengths. We command and control them independently, so we can choose the right light we need, and we can also do sunrise and sunset. And the other trick is that we can dissipate the thermal load with air and liquid. So our growing chamber temperature is not destined to rise because we have lamp that emit hot. Because everybody said that LED is a cold light, but everyone forget that for physical principle, if there is something that emits light, it emits also load, hot. So we have to dissipate this thermal load. And this is why our lamp have this kind of feature.
Well, it sounds absolutely terrific. Do we have questions, Adriano, from the audience?
Yes, Mika Curtis say really great conclusion about many problems on our Earth can be solved by looking outwards. No, it's not a question, it's just a consideration by Mika. Mika is the daughter of Ryan Curtis. I think all of us know about Ryan, and his unfortunate illness he got 1 year ago, and is still facing a rehabilitation path, and we hope he will completely recover his health soon. However, okay. Now I have a question for Enrico and for Giorgia. Recently, I saw a very good speech by Jeff Greason, and I posted it in the Facebook group of the Space Renaissance Initiative, where he mentions, among other things, that we would need a laboratory located outside the Earth magnetic field. So he was talking about L1 as the most appropriate location where to put this laboratory, and this was meant to study the radiations, the protection and the experiment protection from cosmic radiation. I believe such a laboratory could be very useful also to study artificial ecosystems, because of course radiation is something we have to face, not only for human life, but human health and life, but also for vegetables and I mean the whole earthly biome, if you want to try to export it in outer space. So maybe this thing to build a laboratory in L1 could be a proposal that we could maybe advance in our Congress and try to promote it some way in our final resolution of the Congress and so on. So I just would like to ask to the scientists among us how they find this thing could be useful. So for Giorgia and Enrico, basically, and maybe Emanuele too. And
from my point of view, Adriano, it could be like ISS, a great opportunity to make some tests. So it could be an opportunity to select the varieties more suitable for radiation for radiation resistance and so on. So it could be a great idea.
Yes, for instance, I can add that in the Flower of Mars project, we are involving University of Naples, Federico II, and they will develop, they will actually select, let's say select, but even develop some seeds, some plants that, especially with respect to radiation, they should show enough robustness. Actually, there are already, you know, there are some bacteria already on Earth able to survive in a very harsh, very severe radiation environment. By the way, this is, for instance, used also on some studies on the possibility to have some, let's say, treatment of astronauts to survive in radiation. You know that one of the most critical aspects of traveling or going to Mars for people is to survive 2 years of radiation outside the Van Allen belt. And there are, apart any kind of, let's say physical devices that are being studied for protecting astronauts, there is also the possibility to to make a drug that is able to make make people in some way robust to the radiation environment. This we expect this even in maybe more simpler way done also for plants. And as I said before, the idea is the challenging is in fact to make a plant that is able to live on Mars as is. I mean, without any further, apart water that of course you should add in the story, without any special device, any special greenhouse around. This is the challenging aspect of the project. Of course, the project is an artistic project, so we don't expect to invent many things, but at least to stimulate and invent ideas. This we expect. Yes.
Art is wonderful, however. Art Yes, art is speaking to our heart, so it's very, very important, of course.
I wanted to ask one, I know we're running out of time, but I wanted to ask one question of Enrico. Enrico, you suggested that lichen are particularly resistant to radiation, to extremes of heat and cold, etc. Would you use them to terraform Mars? Would you use them as food for astronauts? Would you use them for both?
Microphone. Your microphone. Okay.
Okay, yes. So they of course the lichens can be used for several things, and then we need a lot of research. The research on lichens is started recently. I have a colleague, Professor Nimis, which is a very good expert in the lichens. But there are several kind of lichens, and they are used for food, of course, and then also they are in the first stage of succession on the mountains. So where the ultraviolet ray are strong, and they are resistant. I think that we need research. So if you ask me, just to give you an answer, I can say to you, we need research. We need a lot of research. And then we find something just by chance. But I think that we need to put down experiments, and then experimental designs, and then in place like ICSS or even outside, let's say the
Well, aside from the European Space Agency's upcoming Mars program, which sounds like a very useful thing to piggyback on, Elon Musk is claiming that he will take cargoes to Mars in 2022, which is just around the corner. Does anyone have packages that can be proposed for piggybacking on Elon's first Mars cargo expeditions?
We don't know.
And, you know, so a resounding silence goes through the room.
Oh, well, difficult to say. But actually, this is our dream to have this at least the completion of the project with the piggyback payload shipped to Mars with some mission, of course. I mentioned ExoMars, but I know very well the project, so I think that for ExoMars is too late. But there will be other missions to Mars, I am sure.
So
personally, I dream on space tomato, so I hope to do.
Yeah, space tomato, wonderful. Space pizza. I think we have to leave the floor to give the floor to Howard for his presentation too.
Well, I basically summed it up at the very beginning, and it is basically this concept. Despite a quarter of a century of looking for life elsewhere in the universe, and a large amount of money and intellectual power being spent, we have found no signs of life anywhere else. It's impossible, logically, that if life could take hold here, it wouldn't take place elsewhere. And yet there is no sign of life. And that means life is particularly precious on this planet. Why? Because we are the seed of a cosmos aching to be turned green, aching to be gardened, aching for life. And as I said before, bacteria can do all kinds of things that we can do. Look at our race with the microorganismic community in our current plague with COVID. The viruses are proving to be remarkably adaptable. So research and development is not our greatest gift to the biosphere of which we are a part. Our greatest gift is our ability to get to other barren, hostile balls of stone and to green and garden those places while we take life on this planet is so thin that if you take an airplane from New York City to LA, once you get past Pennsylvania, once you get 1/4 of the way into the flight and you look down, all you see is brown. In other words, to compare life to the skin on an apple is inaccurate because life is patchy on this planet. Life does not saturate, with the exception of bacteria. Life does not saturate every bit of this planet by any stretch of the imagination. And yet, at this early stage, this embryonic stage of the evolution of life, it is our job to take life to other deserts, to other high plains, to other impossible surfaces, to other equivalents of the mountainous terrain that you were talking about, Enrico. And those are above our head. Nature has proceeded through a series of space programs. Initially, all life was in the sea. If you and I had been the parents of those creatures that first wanted to go to the land, we would have said, you're crazy. There's nothing up there for you to eat. There's no place for you to take shelter. And there's no moisture up there except on an extremely sporadic basis. You're going to die on these vast plains of stone you are talking about invading. That was life's first space program, to step out of the sea. Approximately 120 million years ago, there were a bunch of loony dinosaurs. And I'm going to give you their biological interchange in human terms. The youngsters wanted to take to the sky. The elders were shocked. Why? Because everything green and good is on Mother Nature's bosom, is on the face of the earth. There are no places to take shelter, we would have told these ridiculous creatures, up above your head. There is nothing to eat up above your head. There is nothing up there. But this morning, when you got up and walked outdoors, how many of the conservative dinosaurs who clung to Mother Earth's bosom and nature's goodness did you see? Zero. And how many of the loony dinosaurs who wanted to take to the skies did you see? Anywhere from tens to hundreds. They're called birds. And there are twice as many species of birds as there are species of living land-walking mammals. Plus, birds live 60% longer than land-walking creatures their size. Is nature trying to tell us something? That nature is waiting for her next great space program? You bet. We just have to hear it because we are the carriers of ecosystems to the skies. We are the species responsible for gardening the solar system and greening the galaxy.
We have some questions from our audience. Kit Carson writes, what do the panelists think the timeline is for implementing this tech in the cislunar ecosphere? So, did maybe some of us think about the timing? Possible, feasible, reasonable timing?
Georgia, did you hear the question? Do you have an idea of when you're going to be able to take your first completely closed off farm to space? Whoops, we lost Georgia again. You may not be hearing us. Well, Emanuele, you've been pondering this question for taking a flower to Mars. Do you have any idea of when that is likely to occur?
You mean the timing?
Right.
Yes, the question was
timing. It's you know, to set up a mission like ExoMars, they needed around 10 years. So this could be a reasonable time for a project like that. But again, at the moment we are not focusing on the let's say technical aspects of the project. We need first to collect the ideas and to collect also people and initiatives around this project.
And funding.
But again, typically, from the idea to the let's say landing on Mars, you need about 10 years in a typical space project. This is
Well, one note, the Russians have been growing things on the International Space Station for probably something like 7 to 10 years at this point. When the Chinese landed one of their Chang'e rovers on the moon, it carried sprouting seeds. And the Chinese watched as those seeds sprouted normally, and then they were killed off by the environment of the moon. They weren't prepared to go through a full life cycle. But the Chinese proved that they could take life to the moon and keep it viable. We've proven that too with humans. And when you put a human into space, you are putting an entire ecosystem into space. You are 100 trillion cells. Half of those cells don't even call themselves you. They're a vast bacterial colony living in your gut, in your throat, on your skin, and performing normal functions that you think you can perform, like making vitamins B and vitamin K. So if I put, let's say, Enrico or Giorgia into space, I've put a whole ecosystem into space with at least hundreds of species and probably thousands or tens of thousands of species, all working together in synergy.
Yeah. Sorry, we have Jerry Stone with us. And in one of our previous webinars, he presented his project that is called Island Zero. That is a kind of prototype of the on-ale concept for an artificial habitat. So maybe we can give a question to Jerry. In his project Island Zero, what will be the place, the room for vegetables and artificial ecosystems, and let's say to cultivate something to make people eat on Island Zero?
Thanks, Adriano. Nice to be with you again. So Island Zero is intended to be made up of either 6 or 8 inflatable units,
okay,
that would be tethered to a central unit, and they would rotate as a whole to provide a simulated gravity at not necessarily 1G. I mean, this came out of a project which I set up at the British Interplanetary Society back in 2013 to review and update the original studies from the 1970s from Gerard O'Neill and his colleagues. It had always been assumed that space-based habitats would rotate to provide 1G. And my very first question to the group, and I said, I don't expect an answer from you because at the moment, nobody knows the answer. But the question is, do we need 1G? What about 0.9, 0.8 or less? That would mean less stress on the structure, so you don't need as much material in building it. It's also less stress on the inhabitants, on their cardiovascular, on their skeleton, on their muscles, and so forth. But the reason that the answer is nobody knows is we have never done it in space. The ISS is deliberately designed as a weightless laboratory. And the other point was that when you start to build these habitats, you don't start off immediately by building an Island 1, a 10,000 person habitat. You need to make the assembly facilities to put the pieces together. Before that, you need to make the manufacturing facilities that are going to extract the elements, the minerals from the lunar soil and from asteroid material And in order to do that, you're going to need housing in space for the workforce. And so we came up with, there's island 1, island 2, island 3 at different scales. So we're going the other way. So we've called it island 0. So we have these things, inflatable units rotating, and probably 2 out of 8 units would be given over to food production. So the cylinders we envisaged as being 5 meters in diameter and 15 meters long, split into perhaps 4 floors. And so you could have various levels. With the agricultural ones, we could probably have more levels, because if they're really for growing crops, you don't need full headroom for a person in there. But the thing is that we can investigate various things, and also things growing at different levels of G, below 1G. Our immediate feeling was that there should be some degree of gravity, because that's how most plants and crops work, that the roots will go down and the main part will go up, and gravity will definitely be a help there. Plus, of course, the head unit will be going towards light. So we try out different light frequencies and so forth, and see what works best.
Yeah, sorry, a question for Giorgia and Enrico. Do you think that gravity and light process are important for cultivation in space, or do you think that we can also cultivate in low gravity and zero gravity? And okay, light can be done by LED inside inside a closed environment, but what about gravity? Is that important for the growth of plants? Or I mean, on Earth they grow from Earth to the sky, and in space, what will plants do? We should reproduce. I mean, okay, it's a complicated question, I know. From the human point of view, for me, it is very much important to have 1G. Of course, Island 0 should be, as I understood, a first prototype, a small scale prototype, just to start experimenting with artificial gravity. And of course, with a small infrastructure, the Coriolis effects and all these kind of things are very much important. Therefore, we can maybe accept to have I don't know, half G or less than 1G. But when we will have Island 1, the on-air model that will be for 10,000 people, I think it will be big enough to have a slow rotation and to guarantee 1G, because it is big and it is rotating slowly. Therefore, the Coriolis effect will be lower. Then at that point, I think for humans, it's very much important to have 1G, because we will not change our physiology. We can go back to Earth when we want without being constrained on an arm chair, on a wheelchair. So this is for humans. But for vegetables, I don't know, but just I'm not a scientist, but just from an intuitive point of view, I could maybe accept that we have an intermediate ring inside. If this is the big wheel, we have an intermediate wing with 0.5 Gs, and we can also cultivate with that gravity that is lower than 1G. Okay, question mark for our scientists.
So if I can answer, say a little bit, I can say that it depends on the plants that you want to breed. Okay. Because small plants are not much affected by gravity, but the bigger plants, yes. So and NASA is studying the effects of gravity on lignin production of plants. So that lignin is the component that make the stem. So if you just breed vegetables like for the horticultural purposes, just for food, like cabbage, these things, maybe gravity is not very important. And if you breed algae, maybe in the water and some water also there is not important. But gravity start to be important for plants that are more, let's say, that need lignin, that are growing towards in some direction, that not that remain at the ground level. So it depends. Maybe the say photosynthetic process, I think that is not affected by gravity. So, but the other metabolic components, maybe yes. So the growing maybe yes, they could be affected. But there is not much important for me if we use just the vegetable for food, the small vegetable. I think that we can breed with and even if we use algae for oxygen production, for example, it will be very good in outside in the cylinder of an egg. So in what structure that we want.
Yeah, thank you for that, Enrico. Something that I calculated with regard to the original Island 1 design, which was a sphere, was that if you're going to have 1G around the equator, as it curves out towards the big ring windows, at the edge of those windows, you would actually only have 0.7G. And so I suggested early on that if we were going to retain the sphere design, then the housing should be around the equator. So people are sleeping under 1G. That's where they would actually spend most of their time, in the 1G section. And we'd have the working areas further out. In fact, what our group came up with, they reckon a better design was a cylinder. So everywhere on the main surface would be at the same G level.
Yeah.
It's very interesting.
Okay. Any other consideration?
Yes, there's one major consideration. When you're going to take a 2-month-long trip to Mars, some people are going to want to stay there. That was already indicated about 5 years ago by a program out of Holland. A lot of people volunteered a one-way trip to Mars. But if you're going to go to Mars to stay, you need to be able to reproduce. And research about 15 years ago indicated that you can't develop a normal fetus, a normal embryo in 0G, that you need gravity. So the question will be, is the gravity on Mars sufficient to allow for the development of a normal embryo so that humans can reproduce? Or do we have to build cylinders, rotating cylinders, on Mars or under the surface of Mars in order to get 1G?
Or in orbit, on Mars orbit.
Right, that's true.
Why not? Why not?
Yeah, there are also plans for 1G lunar set up, where you effectively have essentially a centrifuge. So you build that on the surface and the whole thing rotates, and that becomes the living structure. So you're sort of flung out around.
Who's developing that, Jerry?
Yes.
Who is behind that one?
Oh, I can't remember offhand, but if you want to dig that out, I'm sure I can send it a reference. But I imagine if you just Google Lunar 1G.
Yeah, that should do it.
Yeah. Yeah. It seems to me that it's a bit of a complicated way of doing things. I mean, certainly for getting to and from Mars. One thing I liked about the Mars Society's Mars Direct mission plan was that the landing craft would have the final stage as a sort of counterbalance, and they'd be connected by, I can't remember, I think it's about 1/4 kilometer, and the two units would rotate to provide 1/3 G on the way to Mars, so they would arrive already acclimatized to the gravity.
I saw
sense, of course.
I saw a video from SpaceX. The idea is to connecting two starships and make them rotate during the trip to Mars. Yeah, around a central hub. Well, so maybe we.
Adriano, if you just to add a few words on this story, following the experience, especially on the space station, it's about clear that people can live only at 1 G. Any difference in the gravity will become a change in bones, muscles, and in short time. Okay, in the space station you have the extreme case because you have 0 G, let's say microgravity environment, but is a disaster for our body.
Sure.
And any variation.
Scott Kelly
why for
plant
it looks it does not look a problem in general. Maybe for trees, I don't know. Nobody tried so far to grow a tree in microgravity environment, but for, let's say, food, the vegetables, in terms of food, they already demonstrated it's not at all a problem, gravity, but for people it is. It is a very serious problem, and today we cannot go to Mars. I must say, we cannot go to Mars if we don't solve two problems: gravity and radiation.
Of course,
these are the two aspects that must be technologically resolved before going to Mars. Otherwise, I mean, there is no way, because the trip is too long, and we cannot survive that situation. This is already clear. I mean, of course, it's not demonstrated by test, but is demonstrated by analysis, at least. Sorry, people, we have to leave, as we said. So we are very sorry to say goodbye.
No, but no problem. I think we covered our theme of this evening. So I'm very happy for this webinar, for the very high profile of all the presentations. And yes, Howard, I think we made a good job this time.
Yes, Adriano, you've been spectacular. All of you, you've been wonderful, absolutely wonderful.
Thank you. I mean, it's
okay.
So, Emanuele, Alessandro, have a good flight.
Okay.
Bye.
Thank you.
Bye-bye.
Georgia, you too.
Just before we'll go, can I ask one question? Coming back to finding life elsewhere, and it was mentioned that you start flying across the United States and you see lots of brown. But on the other hand, everywhere where there is water on Earth, which is 70% of the planet, you will find life there, which is why NASA developed this philosophy of follow the water on Mars. But as for life off the Earth, firstly, there's the question of ALH 84001 and whether you believe that is just contamination from the measurement instrument itself, which doesn't sound very clever, does it? But my main question would be to ask people what they feel about the labeled release experiment on the Viking landers, which gave a very positive result until it was pointed out that the mass spectrometer had failed to detect any carbon. And so they said, oh, well, if there's no carbon, it can't possibly be life. And it was only much later that it was shown that the mass spectrometer was very badly flawed and couldn't possibly give the results it was meant to. And my question has always been, if you discount the mass spectrometer, then did Gil Levin's experiment back in the summer of 1976 actually detect life on Mars? I'd be interested to hear what people think. Everyone's staying off the fence there.
I think everybody is stumped by that one.
I mean, but my follow-on from that is, why have we never repeated that experiment to see if we can get a definitive answer?
Well, those are good questions.
Yeah, I think
but I don't think we have answers.
I think a definitive answer we have when we go there and see. Because you know what? Machine cannot do everything alone.
No.
Because they are not prepared to face unexpected situations.
Mm.
So there's one thing that bothers me about the focus on determining whether there's life on Mars, and that is the absolute commitment to taking sterile spaceships to Mars. At a certain point, we have to stop looking for life on Mars and start planting life on Mars.
Yeah.
Even if it's life that comes from Earth. And we can't be so conservationist that we kill off the possibilities of life on showing what it can do with its evolutionary strategy. As I said, on other gravity balls, on other hostile balls of stone, including Mars, especially Mars.
Yeah. My line on the entire subject is something that I came up with many years ago, where I say, is there life on Mars? Maybe not, but soon there will be.
Yes, excellent.
Okay, I think on this positive note, we can close this webinar. So thank you, everybody, very much for your participation. And thanks to the people who attended and will attend to the YouTube, because it will be recorded on YouTube and available for next days and months. Okay. Don't forget to join Space Renaissance membership. Okay. Thank you very much. Ad astra.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Have a good night or afternoon or whatever it is.